Welcome back, ladies and gentlemen. So we're looking at some Doppler's effect. Now, when we talk of Doppler's effect and the sound, this is the most challenging topic, mostly for students doing A-levels, college students. This is mostly these people fail to understand how to answer questions on Doppler's effect. Let's look at the question we have here. A whistle of frequency 540 Hz moves in a circle of radius 60.0 centimeters at an angular speed of 15.0 radians per second. What are the lowest and the highest frequency heard by a listener a long distance away at rest with respect to the center of the circle? So the first thing we're going to do here, let's correct the data. We see what we're given in the question and then try to analyze the question. So in here we are told to say this whistle, a whistle of frequency. So the frequency of a whistle, we're going to say this is just simply the frequency of the source, because it's a whistle that is producing sound. It is 540 Hz. Then also we're given the radius of this circle made by the whistle as it rotates. It is 60.0 centimeters. Now we want this to be in meters, so we're interested in this to be in meters, so we divide by 100, this and that will go. So our radius will be equal to 0.6 meters. And also we're given the angular speed. So angular speed is just simply equal to 15.0 radians per second. So since we're given the radius of the whistle and the angular speed, we can also calculate the speed of the source, the speed at which the whistle is moving it, which is just simply the radius multiplied by the angular speed. So the speed of the source will be equal to 0.6 times 15, which is just simply equal to 9 meters per second. Right. Now, in this case, we have our whistle. Let's say this is our whistle here. Yes, it rotates in this manner. Then we've got an observer who is at rest. So this observer is at rest. So speed of an observer is just simply 0 meters per second. We want to find the frequency of an observer, the range of frequencies of an observer. Now, since this rotates, let's say it rotates towards him and also it rotates away from him. Now, one thing we need to know is that when the source approaches, when the source moves towards an observer experiences high frequency. Then when the source moves away from an observer, the observer experiences low frequency. This is what we have. So we've got high frequency and low frequency. This is what we have. So now we can answer the first item is saying the lowest frequency. So the lowest frequency is when the source is moving away from the observer. So in here we're saying the lowest frequency. So frequency of an observer is equal to the frequency of the source. Then we try to analyze this. So one thing we need to know is that always here on top we are comparing the speed of sound in air and the speed at which the observer is moving it. Now in here we're going to say the speed of sound in air, it is just 340 meters per second. So here on top always we're comparing the speed of sound in air and the speed at which the observer is moving it. Now this observer was stationed, is at rest, so he is not moving, so we're just simply talking of the speed of sound in air. Now always at low frequency is when the source is moving away from the observer. Now always when the source is moving away from the observer, what happens to the speed of sound in air and the speed of the source? They add. So when the source is moving away from the observer, the speed of sound in air and the speed of the source, they add. So here we're saying speed of an observer is equal to frequency of an observer is equal to frequency of the source. The frequency of the source is 540. Speed of sound in air is 340 over speed of sound in air is 340 plus 9. So frequency of an observer will be equal to 540, 340 over 349. This is our low frequency. So we're dividing the 340, divide by 349, multiply by 540. So frequency is 526.07 Hz. So this is the low frequency when the source is moving away from the observer. Then the second one, we're talking of the highest frequency. Now when does an observer experience high frequency? An observer experiences high frequency when the source is approaching. So frequency of an observer is equal to frequency of the source. Then now we try to compare. Always on top, it is the speed of sound in air and the speed of an observer. Now in this case, an observer is stationed, so we're talking of the speed of sound in air. Now, since the source is approaching, when the source is approaching, The speed of sound in air subtracts minus the speed at which the source is moving with. That is high frequency. So frequency of an observer will be equal to 540 as the frequency of the source, 340 as the speed of sound in air, 340 minus 9. So in here we have 540, 340 over 340 minus 9 is 331. So at high frequency, you're dividing 340 divided by 331 multiplied by 540. So this is 554.68 Hz. So this is the high frequency, this is the low frequency. Thank you very much guys for watching. This is how we answer the Doppler effect questions. Don't forget to like, to share, and to follow the page for more videos.